Let's say you're given a equation of y is equal to e to the power of x, and you also get another equation which is y is equal to 4x. Now, if you start plotting them on a graph, so this is what you will get: e to the power of x. This is e to the power of x, and this is e is equal to 4x. Now you want to find a root of this equation. Finding a root of this equation is simply, you cannot solve it algebraically. So the only way you can find the roots of this equation is by approximation. And to approximate the solution, you can do it this way. So this is why this is called numerical solution of the equation. So you have e to the power of x is equal to 4x. So that means x is equal to e to the power of x over 4. To the power of x over 4. Now, first, for this one, I will try. First, let's say we have this, and first I will try x is equal to 1. So x1 is equal to 1. So now we will try x1 equal to 1. We will place it into e to the power of x, and then we find the new x. So now it might seem weird, but it will start to make sense. Say we have x is equal to 1. This is x. So x is equal to 1. So e to the power of x is about 2.7. So here we have this is 2.72. So this is not equal to 4x. 4x is 4, and this is not equal to 4x. But if we starting to consider this, 4x is here. If we started to equate e to the power of x equal to 4x, this is the new point we're getting. And if we divided it by 4, this is 4x. If we divide this by 4, we will get the new x. So that will be our x2. So that's the same as the equation. So we take x1, e to the power of x1, divided by 4, and we got x2. So here x2 is 2.72 divided by 4. That get us 0.67, 0.680. This is 0.680. Now if we take e to the power of that, this will get us 1.97. And similarly, if we just equate this to 4x and divide by 4, we get our new x. So this is x3. x3 is equal to about 0.493. So we have this point. So this is x3. Similarly, if we get another e, so we got this e, and we equate this to 4x, we got another x, and this is x4. Now if you imagine, the more you do this, the more you actually get closer to the root. So the more you do this, the more you get to this point, and this is the point where e to the power of x actually equals 4x. So this, if you continue this trend, so I'll just replace the numbers, and then I'll get the consecutive x for you to see. Right, so the more you do it, you can actually realize that the roots starting to converge into a number, and if you actually do this more, you get it down to approximately 0.357, and this is the actual roots of e to the power of x equal to 4x. If x would equal to this, so if you continue this trend, it converges into this one, and this get e to the power of x to be equal to 1.43, and for 4x that is 1.43. So this is the idea of writing x as equal to another function of x, and start replacing, x1, and then you get x2, and then consecutively, finally you will end up with an approximation that is really close to the root of the equation. So that is the idea of how you define a numerical solution for an equation that cannot be solved algebraically.